Hello, Algebra 2 students. Mrs. Myers here. We are now moving on to lesson 12, but this really is not any different from what we were doing in the previous lessons. We are still working with sine and cosine graphing, but instead we are now going to be taking a look at some applications of it. So basically, we're going to take a look at some graphs and see what the equations are that go along with them, and we're also going to take a look at some graphs that or some equations and see what kind of questions can be answered from that. Okay, so we're going to do a bunch of problems together for notes, and then you got a bunch more that you'll do that are likened to what the notes are that you're going to do for your problems. Okay, so let's take a look at the first one here. It says which graph is represented by which equation is represented by the graph below. So first thing I notice is that, okay, with multiple choice, right, sometimes it's easy to eliminate some wrong answers right away. So if I take a look at this graph, you see how it goes from max to midline to min to midline to max? Well, right away, that says cosine to me, so I could just get rid of choices 2 and 4 because that doesn't even say cosine, all right? And then I want to see what else can help me decide which of these is the right equation versus wrong. Now, they all had a 2 right up front, okay? There's a reason for that, right? Is every single one of them is showing a dilation of 2 to the y's because the amplitude is 2, right? See, the vertical change from midline to max, right, is 2. So that's not a discerning factor. I know that that's got to be a 2 right there. That's why every single equation had that. Now I'm going to move on to this right here. Okay, see how this is the radian measure that ends the cycle? See, this is one full cycle. That's what's called my period. Okay, now a standard period for sine and cosine should be 2 pi radians. Okay, but it's not. So clearly I've had some dilation to the x's. I want to find out what that scale factor is, because then I'll know what this value should be, right? In here, the multiplier of the x, right? Now, I have to think, what should I multiply 2 pi by in order to get to 2 pi over 3, right? So 2 pi divided by 3 is another way that we can look at this. Well, what I would have to multiply by, though, is 1/3, right? See that? 2 pi times 1/3. Okay, that would give me that 2 pi over 3, right? So that's what I'm trying to figure out. Now, if that is what I multiplied by, then there is my scale factor, right? So I know that I've got to compress this cycle down by 1/3 as my scale factor in order to get to this period of 2 pi that really should have started at a period of 2 pi. Okay, now it's down to 2 pi over 3 because, again, I've horizontally compressed it down to a scale factor of 1/3. But what does that mean about this multiplier? Remember, the outside multiplier is exactly the same as the scale factor, but the inside multiplier has to be reciprocated to be the scale factor. So that tells me it should have been a 3. So now I know it's choice 1. There we go. All right, let's try some more. All right, so which equation is represented by this graph below? So first of all, I don't have that whole sine versus cosine thing in my choices. Every single one of these is sine, okay? Because I'm starting at a midline point. Okay, so midline to max, back to midline. Now, the thing about this graph is it's not one full cycle. See, the other problem, this is one full cycle. This is not one full cycle. So if I wanted to keep going with one full cycle, what would I have to do next, right? So you see how it's 2 boxes to get to pi, right, for this max? So I would have to have 2 more boxes to get to a minimum, and then 2 more boxes to get back to the midline. That is the rest of the cycle. Okay, now not the perfect sketch, but that's the idea. So look at what this says right here. 2 boxes, right, of pi radians to get to the max, 2 more boxes to 2 pi to get to the midline. That would mean 2 boxes later of 3 pi to get to the minimum, and then 2 more boxes later of 4 pi would get to the midline. This is what finishes the cycle. This is my period, okay? So I still have this amplitude right here, which is the vertical change between the midline and the max, or the vertical change between the midline and the min. Notice how I'd gone down to -2 because I went to the positive 2. That's my amplitude. Well, that actually is nice because I only see choices 1 and 2 with that amp of 2, so I can get rid of those, okay? But now, what about this multiplier to the x, okay? So if this is the radian measure, okay, that ends that cycle, then I know that that's my period. But the standard period for sine and cosine is 2 pi radians. Well, what do you have to multiply 2 pi by in order to get to 4 pi? So that's easy. That's 2, right? So now, see this multiplier? Now I know that I had to multiply, right? Okay, I had to do a scale factor of 2 with respect to my x's. I had to take a standard sine cycle and I had to stretch it out, right, by scale factor 2 to get to a period of 4 pi that really should have only been a graph that started at a period of 2 pi. I had stretched out, right? So again, what is that multiplier though? Okay, that multiplier is always the reciprocal. So that's got to be that 1/2 right there. So I'm actually at choice 1 again. All right, going on to the next problem. So we've got the Ferris wheel at the landmark Navy Pier in Chicago takes 7 minutes to make one full rotation. The height h in feet above the ground of one of the 6-person cars can be modeled by this lovely equation. Okay, take a look at that, real good. T is the time in minutes for this equation. Okay, h is the full rotation that the car, one of the cars in the Ferris wheel makes as it goes around and around and around, okay? And what we want to know is what is the minimum height of one of those cars. So what this graph looks like, so this is a sine cycle, okay, is that standard, like, right, so midline, max, midline, min, midline, okay, but with lots of transformations. Now, really, what transformations do we need to pay attention to? Let's not make more work for ourselves than needed. I really just need to pay attention to the y-axis. Okay, that's really all I need to concern myself with, because it just says what is the minimum height of the car. So this right here first has been dilated by scale factor 70 to the y's. I can see that multiplier that's outside. So according to just that, I would have a max of 70 and a min of negative 70, but that's not the end, okay? I mean, your Ferris wheel can't have a minimum height of negative 70 feet, you know, if we're thinking about, you know, 0 is ground level, right? You're not going to go below the ground. Well, there's something else. See this plus 80? That tells me that the whole graph is going to go up 80, right? So that's going to change my midline, okay? My midline is going to be right here at 80, okay? And the whole graph is going to go up, right? So that what was the x-axis before with the graph is now going to be up there. So this midline point is going to be at 80. This maximum is going to be all the way up there. Oh, pardon my not so good sketch here. It's going to be all the way up there at 150. Okay. Then I'm going to come back to the midline. Then my minimum, okay, my minimum is not going to be negative 70. It's going to be 80 higher than that, which is going to be at 10. And then back to midline, okay? So I can see here that the graph has been moved up. Now, granted, it's also changed in the period, and I'm also doing a phase shift, but again, I don't need to concern myself with that, okay? So I just want to know what is the minimum height, and that's clearly right there at 10, so that is choice 3, okay? All right, another one of these multiple choice questions, then we'll get some short answer questions. So the voltage used by most households can be modeled by a sine function, okay, so voltage for your electricity. The maximum voltage is 120 volts, and there are 60 cycles every second, which equation best represents the value of the voltage as it flows through the electric wires, where T is the time in seconds. Now, one thing is the same throughout all of them, and that is this multiplier outside is 120, because the maximum voltage charge is 120. So I know I'm going to have a maximum positive 120 and minimum of negative 120. So all those have that 120. So that's not a discerning thing. But I got to go to this. See, there are 60 cycles every second. That's an important thing, okay? Because that's what's going to change all these multipliers inside my function. Now, it's not giving you an x variable. It's giving you this t variable instead. That's what was in number 3 too. And it says that t is the time in seconds. Okay, so that's kind of like your x value. So what I'm basically have to figure out is if there are 60 cycles every second, okay, what does that mean about my period of my graph? Okay, so this is sine, right? Okay, so what is this right here? What is that number of seconds, okay, that's needed to complete one cycle? See, there are 60 cycles every second. So if I repeat this 60 times, whatever, okay, by the time I get to the 60th one, that's only 1 second. That's what that means, okay? 60 cycles to get all the way up to 1 second. So how many seconds, how long does it take to complete just only one cycle? Well, that would be 1/60th, right? So now I can see that my period is 1/60th of a second. Okay, well, the thing is that for sine and cosine, your period should be 2 pi, Well, clearly I've got to multiply it by something to get down to 1/60th though. So I would have to multiply by 1 over, okay, because I got to get 1 in that numerator, right? So it's got to be 1 over. Now 2 is going to have to reduce with something to give me 60, so that would have to be 120. And I don't want the pi there. See, there's no pi, so I'm going to have a pi there as well, because this way the pi's will just cancel right out. And then 2 would divide into 160, 120, 60 times, leaving me with that 1 over 60, and voila, there's my period, okay? So now I know that I had to dilate by 1 over 120 pi to my x's, okay? See that multiplier right there? Okay, 1 over 120 pi. I know that that is what my scale factor was that I had to multiply by. But notice how that's not any of my choices, because this is always the reciprocal of the multiplier. So what's the reciprocal of 1 over 120 pi? It's 120 pi, and there we go. So I'm looking at choice 4. Okay, let's practice a few more of these, but this time not multiple choice. Let's time do short answer. So same idea though, where now you're looking at a graph. Okay, 2 problems where you're looking at a graph, but you have to actually write the equation on your own. So no multiple choice. But this shouldn't be too bad, okay? So first things first, we're looking at a sine graph. Sorry, not a sine. We know we're looking at cosine, but not cosine the way that we would typically think to see it, because that would have a maximum first, but a minimum. So the fact that I know I'm going to a minimum first means I definitely had to have a reflection over the x-axis, which means I definitely had to have that negation, right, in the equation, right? I'm just going to keep that in mind, okay? I know it had to be outside, because, high, low, right? Okay, so over the x-axis is vertical, so vertical has to be outside. Now, I also know that this amplitude is 2. Okay, that's been changed from what would be an amplitude of 1 as being stretched out. So I know I'm also doing a dilation of 2 to the y's. And last thing is a horizontal dilation. Do I have that at all? Well, look, the cycle finishes exactly at 2 pi the way I'm expecting. So I have no horizontal dilation at all, okay? So this is just y equals, okay? 2 has to be for vertical, it's outside. The negation is for vertical, so it's outside. So it's -2 cosine x, and that's it. Okay, I don't have any vertical translation going on or any phase shifting going on at all. Okay, I don't have any horizontal dilation because my period ends at exactly 2 pi, so I'm good to go. All right, 2 more to go. Let's take a look at this graph. Now, this one is also cosine. Okay, this time I do not have the reflection over the x-axis, because notice I'm starting at a max. Okay, but my midline is not on the x-axis. This is tricky, okay? So let's definitely know that I gotta have a vertical translation here, and then here's my minimum. So look very carefully at these values. See, the maximum is at 4, right? And that minimum is at -2. So they're not exactly just negations of each other the way these always are, right? See, 2, -2 for min and max. So I know that my graph had to be shifted. And I definitely had to shift up, because look, the max is at 4, but the minimum's at -2. Now, where's that midline, right? What's exactly halfway between those, right? So just average them, right? Add them together and divide by 2. So 4 plus -2 divided by 2, 2 divided by 2, there's 1. So that's where my midline is. All right, and now I can see perfectly that the distance, okay, from the midline to the max is 3. So there's my amplitude is 3, which is the same as when I look from the midline to the minimum, right, between 1 to -2. There's still my amplitude of 3, okay? So I know that I'm dilating with 3 to the y's, okay, because I have that vertical change there from midline to max, right? My cycle, look, max, midline, min, midline, max, that only takes pi radians to complete, okay? So I definitely know I'm going to be dilating with respect to the axis too. So my standard period should be 2 pi. It's not 2 pi, it's only 1 pi. So this shouldn't be too bad. I have to multiply by 1/2 to get to pi, right? So now I know that I'm dilating with 1/2 to the x's, and that means that I have this reciprocal as the multiplier inside my function. I don't have any reflection over the x-axis because I started a max, not a min, okay, for the cosine graph, and I've got this midline here, so I know I'm going to go up 1. All right, so anyways, I have y equals 3 cosine of 2x plus 1 is my equation when I take all of these things into account, right? So dilation of 3 to the y's, there's that multiplier of 3 outside, right? Dilation of 1/2 to the x's, so there's that multiplier of 2 inside because that's the reciprocal. And then finally shift up 1, so there's that plus 1 on the outside. If you want to put parentheses, that would be parentheses like that. Make sure you don't put that plus 1 inside, okay? All right, last problem. Okay, so it says the graph below represents the height above the ground age in inches of a point on a triathlon's bike wheel during a training ride in terms of time t in seconds. And here's what that looks like a little bit. Now all it says is to identify the period of the graph and describe what the period represents in this context. So we don't really have too much to do for this problem. We got to look at this graph and figure out what period it is. So we've done a couple of these already with cosine, because that's clearly what this would be as an equation. So we've got a max of 25. We've got this min 0. So obviously it's halfway in between, right? There'd be this midline, and then back again to the midline and the max. So this is one cycle, right? See that? That's one cycle. Now they showed you a second cycle and a third cycle, and it would keep going on and on and on. So period is the amount of time it takes to complete one cycle. So that's right there. It would be period equals 2/3, and this is in terms of seconds, right? So what is that 2/3 all about? Okay, so the period, so it says, what does this represent in terms of the context of the problem? Okay, so think about it. If we have a point on the point on the wheel right there, that's at that maximum 25, because it's a 25-inch diameter tire, that point will go around and get to a midline, see right there. Then it'll keep going around and get to a minimum, see right on the ground. Then it'll keep going around and be at another midline, see that was right there. And then it would keep going all the way around to the top, and it would be right back to the max. And the reason why it would do it again and again and again is because the tire would just keep going around and around and around. So that point would just keep going from being 25 feet above the ground to 12.5 feet above the ground, 12.5 inches, to right on the ground. And then 12.5 inches above the ground, and then finally 25 inches above the ground again, right? So what is this 2/3? It's how many seconds, okay? Represents, okay, time for a tire to make one rotation. And that's it, okay? Because that's it. And when you go from max to midline to min to midline to max, that's just the tire rotating around one time. All right, so hope you felt okay about these questions from the notes, and then you're just going to do some problems just like this for your homework. Make sure that you do what I did though, which is to mark up your diagrams, show me everything that's needed to get you to the answers. Multiple choice does not mean multiple guess, okay? Doesn't mean multiple guess. Make sure you show me why you're choosing the answer that you're choosing. All right, hope everyone is well. Bye.